What I want to do is just a couple of lectures, some chapter dealing with overview of organic reactions. These topics you will learn later on, but just want to give you a brief introduction to reactions. So if you're given this structure here, and we're going to practice using curved arrows to show electron flow. And matter of fact, I'm going to cut the molecule off here at this point. For the ones that have the textbook, you'll find the complete structure. I'm going to just do this because there's more structure occurring, but it doesn't really have any bearing on the actual topic that we've got going here. And I've got one more double bond to draw here. So the question is, if you are asked curved arrows, the use of curved arrows chemists use to show electron flow. So we know this dash here is 2 electrons. So if we're trying to show a bond being formed between this carbon and this carbon, the question is, how can you do that with curved arrows? Well, these 2 electrons here, so in other words, I'm going to draw a dotted line maybe between these 2 carbons, because again, these 2 carbons are going to have a new bond. So 1 electron can be donated by this radical here. We know a radical is 1 lone electron. And this bond has 2 electrons, so 1 electron can break and go here. And these half arrows are trying to show, depicting the movement of the electron here. And then 1 electron can go here. So in essence, what you end up having is your final product is now a new bond being formed right here between this carbon and this carbon. And now the other electron is right here. And again, the molecule goes on. So what we're trying to show here is with the arrows, the curved arrows, is trying to show the electron flow as you go from one compound to another. So let me just another couple examples. And these are from within the overview of organic reaction chapter. Again, we will be talking lots about these curved arrows in the future, but trying just to get us a little introduction to that. So let's look at this example here. If you had chlorine, and we know chlorine is diatomic, so it has its other octet, its lone pairs here. If we were reacting that with ammonia, and if the question was, how do you show with curved arrows, how do you show the formation of this product? That's a plus sign there if it's hard to see. And we have this other product. So again, with curved arrows, how do you show these products being formed? Alright, so you can look, you can see in the reactants you have a nitrogen here with 3 hydrogens. In the product you've got it with chlorine, so you got to somehow show how does chlorine get added to that. Because again, you can see that bond has been formed between nitrogen and chlorine, and then you've got a chlorine that's been kicked out. So if you would have the arrows going from the nitrogen to the chlorine, and then this bond breaking, and the electron, both electrons in this bond are going with the chlorine. So that's why you can see it has a negative charge, because here, this electron here was donated by this chlorine, but now this chlorine has both electrons, because so it's picked up a negative charge. Here, in the nitrogen in the reactant, it has its lone pairs, both associated with nitrogen. Being visualized over here now, visualize that one of those electrons are being donated to chlorine, so it's like nitrogen is giving up 1 electron to chlorine, so that's why it has a positive charge. So the curved arrows here are showing the movement of electrons. The tail of the arrow is from the electron, where the electrons are coming from. The head of the arrow is where they're going to. So let's do one more problem with curved arrows. And we'll stop this. And we'll be doing a lot more of this as the semester progresses, but just trying to give you a little overview from the reaction chapter, just to give you a little flavor for how curved arrows can be used to show where the electrons are going. All right, so if these are reactants, and our product then is this, and the question is, how do you show with the aid of curved arrows the formation of these two products? All right, once again, you might help just to pause a minute and see what's going on. You can see over here the methoxide, and I can go ahead and left off the negative charge over here. Sorry about that. So oxygen has a negative charge because it's extra electron there. So you can see that over here oxygen has picked up the CH3 group, and we've kicked out a bromine. So if we showed, so again, a bond is being formed between this oxygen and carbon. So the bond is being formed between one of the electron pairs here. So again, the tail of the arrows from where the electrons are coming from, head is where they're going to. You see this bond is being broken. So the electrons are coming from this bond to the bromine. So you can see oxygen over here is neutral because one of the electrons that it had now is being donated to the carbon. The reason bromine is negative because, again, if you look over here, this bond has two electrons. If you say this one came from carbon, over here it has both of them, so it's like it's picked up an extra electron. So the curved arrow is a nice convention to show where electrons are coming from, where they're going to. All right, I hope this helps in understanding the flow of electrons. Again, we'll be doing a lot more practicing in the future. If you have any questions, contact me. But this ends this video lecture capture.